Have you ever been sitting on a plane, maybe looking out the window, and just wondered, how did the airline even decide to fly this route? I mean, how do they know that a flight from, say, Portland to Paris is actually going to work out? That's a multi-million-dollar question, and today we're going to look at the AI that's getting seriously good at answering it. Okay, so this image right here really nails the problem. You've got this whole web of existing flight paths, right? But look at the gaps. Figuring out where those red dashed lines should go, now that's the huge challenge. It's a puzzle for airlines who are always looking for the next big opportunity, and for cities trying to figure out their future growth. To even begin to solve this, researchers realized they had to completely change how they looked at the problem. They had to stop thinking about single flights and start seeing the whole massive picture. It's a total shift in perspective.
Yeah, this is not just a guessing game. You can't just throw a dart at a map. The world's air travel system is like this living, breathing, incredibly complex network. Every single airport, every single route actually affects every other part of the system. So if you want to predict one new route, you have to understand the entire web.
Now, this is where the big aha moment happens. The researchers took this messy real-world problem and translated it into the super clean, logical language of math. They basically turned every airport in the world into a dot or a node, and every flight path became a simple line connecting them, a link. Suddenly, the whole planet is just one giant graph.
And once you see the world that way, the problem gets a formal name, link prediction. But here's the really cool part. This isn't just about flights. You know how social media platforms are weirdly good at suggesting new friends? Or how shopping sites seem to know what you want to buy next? That's link prediction. It's all about finding the connections that should be there, but just aren't, yet.
Okay, so we've got the theory down. We see the world as a network. But how in the world do you teach a computer to actually see these potential new flight paths in a network of thousands of airports?
And that's a really good question, right? I mean, a computer just sees data, ones and zeros. It has no idea that London Heathrow is this massive international hub and that a small regional airport is a completely different beast. So how do you teach it that difference?
Well, you give each airport its own unique digital identity. The technical term is embedding, but you can just think of it like a digital fingerprint. It's this long string of numbers, a feature vector, that basically describes everything that makes an airport special and what its role is in that big global network.
And what's actually in this digital fingerprint? Oh, it is incredibly detailed. The model looks at 738 different features for each and every airport. We're talking about which of the 568 different airlines fly there, what kinds of planes they use, whether routes are code shares, even the number of stops. All of those details get cooked down into that one unique signature. And this is what makes this whole approach so powerful. It's something called inductive. What that means is, if a brand new airport opens up tomorrow, the AI doesn't have to go back to school and relearn everything from scratch. Nope. It can just look at the new airport's features, create a fingerprint for it on the fly, and immediately start figuring out where it's likely to connect. It's fast, it's efficient, and it's built for a world that's always changing.
All right, so the theory sounds solid. We've got these digital fingerprints, this really clever inductive model. It all sounds great, but the real question is, did it actually work? Let's check out the results.
First, let's just get some context here. This was not a small test. The AI was trained on a massive real-world database. We're talking over 65,000 existing routes, connecting more than 3,400 airports all over the globe. So yeah, this is the real deal. And the final result? A staggering 90% accuracy. Let that sink in. That means that 9 times out of 10, the model could correctly predict whether a flight path between two airports was real or not. That is just an incredibly powerful performance. And this chart, it's like we're watching the AI's report card as it learns. That top line shows its accuracy, and you can see it shoots up super fast and then just hangs out at that high 90% mark. And the bottom line? That's its error rate, which just plummets. With every single training cycle, it was literally getting smarter and more confident.
So a 90% accurate model that's a fantastic scientific achievement for sure. But what does it actually mean for us, for the future of how we all travel?
Well, the impact here is huge. For airlines, this is a tool that takes a ton of the risk out of that massive investment in a new route. For cities and local governments, it's kind of like a crystal ball for forecasting tourism and planning things like hotels and transportation. It helps the whole travel ecosystem get ready for growth, from passengers to cargo. And in a crazy competitive industry, it can help find those golden opportunities before anyone else does.
So, we'll leave you with this thought. This AI essentially learned the hidden logic of the entire global flight network. If it can map the connections between our cities with this kind of accuracy, what other incredibly complex connections in our world is it ready to figure out? Think about economic markets or the spread of ideas. The future of this technology is about way more than just where we're going to fly next.